All right, our last section, section 15, we'll be looking at permutations and combinations. This isn't something that we usually see in a high school curriculum, so it really may be new for most of you. These are two words, combination, permutation, or uh, what is it? Counting techniques, roughly speaking. Just like you see in the illustration here, how many different combinations can you make with the menu? Things like that. And let me just go ahead and show you the first one, permutations and combinations. I'll show you permutation first. So the definition, a permutation of n elements is an ordering, right, of the elements where order matters, right? Order matters. That's the one thing we got to remember for permutations. And why do we even need to know this? Well, say for example, there were 8 horses in a race. Yeah. And we wanted to know how many different ways can they place from first to eighth, right? First, second, third, fourth, so on and so forth. How many different ways? Well, in this case, order matters because we care about who's first, who's second, who's third, who's fourth, who's fifth, so on and so forth. The way we can figure that out is simply by using factorial. The number of permutations of n elements is simply n factorial. So in this case, 8 factorial. So all the different ways they can place from first to eighth, there are 40,320 possibilities. Now, here's where it gets a bit more interesting. What if we were just interested in how many ways they could place first, second, and third? We don't care about the rest. Simply about first, second, third between those 8 horses. Here's where the new formula comes in. And this one is P. This is just notation of how we write it. Let's go ahead and choose blue. This is just a notation. The P lets us know that it's a permutation. N is the total. And then R, how many you take. Oh man, that says take at a time. And the way this works is up here, they're asking us for about 8 horses. So that's our total. That's going to be N. N in this case is going to be 8. And we only care about first, second, and third. So we care about 3. We're taking 3 at this time. So R is 3. If we plug that into our formula, that's going to give us that the permutation of 8, 3 is 8 factorial over 8 minus 3 factorial, which is just equal to 5 factorial. If you don't remember what factorial means, it just means 1 times 2 times 3 times 4 up to that number. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yeah, so how many different ways can I place first, second, and third? A total of 336. So the number's a lot smaller. That is for permutations. Now, once again, I need to stress this. Order matters with permutation. That's a big thing. Order matters. Now there's something else known as combinations. Uh-oh, I already gave away that. I'm going to give you an example there. A combination of n elements is an arrangement where order does not matter. So what would something like that look like? For example, 5 out of 13 students will ride in a car instead of in a van. So how do we choose, if you had 13 students, how do you choose 5 of those? Well, the formula for combination is this right here, which is exactly the same as a permutation. The only thing that changes is this R factorial is down there, right, in the denominator. That one's added for the combinations. And this one, again, it's just a notation. This C is telling us it's a combination. Another way I've seen people write it or even say it is N choose R, and they write it like that. So out of 13, in this case, we choose 5. And this right here, I'm going to circle it right here, is just another way of writing it as well. Same thing means the same thing. It's a combination. 13 choose 5. But again, we just plug it into the formula. That's all there is to it. This is just computing pretty big numbers, but nothing we can't do. 13 factorial over, what would that be? 8 factorial times 5 factorial would give us 1,287. So out of 13 students who are writing in, or 13 students, if you choose, or if you pick out 5, there's 1,287 possibilities to choose those 5. And now this big example here that I gave away at the beginning, there are 23 soccer players on a roster, on a roster, but only 11 play at a time. So how many possibilities are there for a starting lineup? Now notice here, it doesn't matter what order we choose them in. As long as we choose the 11 players, we don't care about order. So that's how we know it's a combination and not a permutation, so we know what formula to use. And 23 choose 11, that's going to give us a pretty big number. That'll give us that there are a total of, whoa, what is that? 1,352,078 possible combinations of, so you can have a starting lineup. So that's what combinations and permutations are. It really is just comes down to using that formula, identifying whether you need to use permutation or combination, using the formula, and that's pretty much it. Just calculate. Not much to it. All right. Formulas, maybe you might have to practice a bit so that they, engrave in your head, but nothing too bad. Again, with practice.